Morning. Sorry. Good afternoon, everyone.
Afternoon, Miss.
Okay. Okay. So this week is week 12, and you are aware that you need to submit your assignment, kan?
Yeah, by this Friday. Kan?
Yeah, yeah,
Ah,
yeah. This Friday. So I already create the note for you to submit the tutorial lah. It is under this continuous assessment. So you need to submit it here lah. No need turn it in. Okay, because this assignment doesn't need the student to submit to turn it in. Okay, so no need turn it in lah. Okay, so for today, week 12, we will cover the parallel processing. Okay, so this parallel processing actually, if you guys see at your syllabus, it should be under performance enhancement. The this one, the multiprocessing. Okay, so we cover one topic uh, under performance enhancement. Actually, memory enhancement already covered during our lecture in the memory. Last time we have lecture on memory. Okay, so memory enhancement is already covered in that chapter. Okay, so for now, we will only cover, for today's session, we will cover this multiprocessing, which is in this parallel processing. Okay, so parallel processing is actually one of the way of how we can enhance the processing performance of the CPU, of our CPU lah, or processor. Okay, so these 40 slides will be talking about the architecture and how the structure of the processor that can enhance its processing performance lah. Okay, so in this chapter, there are three topics we will cover, which is the parallel processor system, multiprocessing, and multiprocessing operating system. Okay, so what is the parallel processor system? So parallel processor system is actually a processor that able to run a process, more than one process at one time. So that is what we called as parallel processor. But a parallel processing system, there are various system, and it is divided or categorized using this Flynn taxonomy. Okay, so what is this Flynn taxonomy? Flynn taxonomy is the common way of categorizing system with parallel processing capability. Okay, so we follow the categorization, the text. Before that, taxonomy is actually the other name of taxonomy is classification. Okay, so Flynn's taxonomy meaning the classification based on Flynn. Flynn may be someone's name that introduced these categorizations. So we based on Flynn's categorization, we categorize various type of parallel processor. Okay, so these are the categorization or taxonomy of the parallel processor. Okay, so there are 1, 2, 3, 4. Four parallel processor categorization. Okay, so SISD, which is single instruction, single data stream. All of this parallel processor, like I said just now, it is the processor that able to run more than one process at one time. Okay, so the parallel processor can be categorized into four, which is SISD, SIMD, MISD, and MIMD lah. So you can see the name here. Okay, so among all of this categorization, among these four categorizations, only one categorized that use uniprocessor. Uniprocessor meaning it uses only one processor. But although it is used only one processor, it still can run more than one process at one time lah. Okay, so SISD stand for single instruction, single data stream. SIMD, single instruction but multiple data stream. So this SIMD uses two processor, which is vector and array processor. For the MISD meaning it can run multiple instruction or multiple process by using only one single data stream. After that, the MIMD is the multiple instruction, meaning multiple process or instructions lah. And it will be run using multiple data stream. So this MIMD uses two type of this MIMD can be further categorized either it's tightly coupled or loosely coupled. So we will know what is the tightly coupled, what is the loosely coupled processor lah after this. Okay, so the tightly coupled, it is further categorized into SMP and NUMN, which is non-uniform memory access and symmetric multiprocessor or SMP. So the loosely coupled is also known as a cluster processor. Okay, so we will learn all of this after in our next slide. Okay, so SISD. SISD is the first categorization of a parallel processor. Okay, so SISD meaning it can run single instruction by using single data stream. Okay, so SISD is a single processor because it is uniprocessor kan, so it only use one processor to execute a single instruction stream to operate on data in a single memory. So it only use single memory, single CPU, and then single instruction stream. Okay, so SIMD, the second parallel processor, it is the single machine instructions that control the simultaneously execution of number of processing elements. So in SIMD, it is type of parallel processor that enable single machine instruction. It controls simultaneous execution of number of processing elements, meaning single machine instructions can control more than one processing elements. Okay, so SIMD also support macam each processing elements has an associated data memory. So each processing element, it has its own data memory. And then SIMD can use more than one processor, which is vector and array processor. Okay, so it is this topic only cover the introduction punya part, macam only upper level of parallel processor. So that's why we didn't cover what is actually vector, what is actually array. But it is enough for us to know for now at the moment that SIMD will use two type of processor, which is the vector and array processor. And then we proceed to the third type of parallel processor architecture. So this is using this architecture will allow sequence of data transmitted to a set of processors. So this also use multiple processor, and then um, each of the sequence of data execute at the different instruction sequence, and then it is not commercially implemented, meaning this architecture not widely used, but it is actually it exists and invented by someone out there, but what we use now is not this type of architecture lah. So the third architecture of parallel processor is MIMD, which is it can run multiple instruction and it use multiple data. So a set of processors simultaneously execute different instruction sequence on different data sets. So each of the processor it has its own data set. So it has a symmetric multiprocessor. So it also use a multiprocessor, meaning more than one processor. Okay, so if you can see, so this diagram will explain better lah, whatever architecture that we have mentioned here. So SISD, so this is your CPU meaning your processor. So whenever I said CPU, usually people will usually it will refer to a processor. So for SISD, which is the single instruction and single data stream, this is the diagram now. CU is control unit. Okay, so if you remember in our processor, it will consist of control unit, and then it also consists of PU. PU is processing units. And then MU is the memory unit. So for SISD architecture, it only has one control unit, one processing unit, and one memory unit. So this is the instruction stream, how the C control unit pass data to PU, which is the processing unit. It will go through the instruction stream, and then for the data to go to PU and the data exchange between PU and MU, it will go through the DS. DS is actually the data stream. Okay, so for SIMD, the second parallel processor architecture. So it will have one CU because CU is the part that will give instruction. So single instruction meaning only one CU because control unit is responsible to give instruction, and for SIMD it only support one instruction, but it will have multiple data stream. If it has multiple data stream, meaning it has multiple processing unit, because one data stream will involve processing unit and the memory or local memory. Okay, so for the CIMD, it has single instruction but multiple data stream. So that's why it only has one CU, which is control unit, and then multiple set of data stream. Okay, so data stream meaning PU, a set of the processing unit and the memory. Memory is the RAM. Okay, so for the MIMD, which is the third, this one, MIMD, the fourth processor architecture, as it is says here, it use multiple instruction and multiple data stream, meaning it will have more than one CU, which is control unit. But there are two types. It says here there are two types of MIMD. The first one is the tightly coupled, meaning tightly coupled, it shared one memory. Okay, so um, all of the data stream shared one memory. Okay, so this one is the example of the third, the second MIMD, which is it used a loosely coupled architecture. The difference between the tightly coupled and loosely coupled is the memory, because in the tightly coupled it used shared memory, but the second type, which is the loosely coupled, it used distributed memory, meaning each of the processing unit use its own memory or RAM. Okay, so third, the third architecture, which is MISD, like I said just now, it is rarely used. It is didn't use in any industry, but this is the architecture for the MISD lah. It has multiple. It can run multiple instruction because it has multiple control unit. It also has multiple processing unit, and it also have its own memory, but it didn't specify here why this architecture um, are not commercially implemented. Okay, I cannot say anything lah. But as long as we know that this architecture are not commercially implemented. Okay, so we have learned about the architecture of the parallel processing. So you just need to remember there are four architecture of the parallel processing. Okay, so now we are learning about multiprocessing. Multiprocessing meaning the process of processing more than one processes. Okay, so the process of how our CPU can process more than one process or instruction at one time. Okay, so now in this multiprocessing, we learn about the tightly coupled and the loosely coupled system. Because multiprocessing can be done in two different approaches. Either if you remember just now, tightly coupled, it shares one memory, but loosely coupled, it didn't share the memory. It used distributed memory. Okay, so we will know about these two types in our next slide. So if you have any question, you just ask me. You just interrupt me lah.
Okay.
So before we further go into multiprocessing, we need to know what is the interleaving lah. Interleaving is the term or the process of our CPU or our processor, how the CPU can process more than one process at one time. Okay, so for one processor architecture, if previously the architecture that used one processor is SISD, so it used interleaving. The way it is processed, the way it process multiple processors at one time by this interleaving lah. So what is the interleaving is when process one occur or run, the other process should be stopped first. Okay, so when the process to start, the other process need to be stopped first. After it stop, baru yang another process can take place lah. Okay, so it need to be bertukar-tukar at one time. It cannot run simultaneously. Okay, so it is what we call as interleaving. Yes, it can process multi-program and it can be processed by one processor, but how this one processor process these multiple processors is by using interleaving process lah. Meaning it will not run all of the process at one time. It need to be ganti-ganti. Okay, so if one process running and then the other process need to be stopped. Okay, so that is what it called as interleaving. And then for the architecture that has more than one processor, it will use process of interleaving and overlapping. Wait, I think, okay, this one I forgot to ask you guys to watch this video. It is only 3 minutes video. It help you guys to understand more about what is the parallel processing. So you guys watch this first now. Okay, so I have copy pasted a link in our chat.
Okay.
Hey guys, and welcome to another video from Fast Tech Skills series. In this video, I'm going to talk about a very interesting concept, which is parallel computing. This topic, or this way of computing, I should say, has been very, very popular in the past years, and there's a specific reason why, which I'm going to discuss in this video. But let's have a look at traditional computing, the type of computing which is not parallel. So we have the processor here, and the instructions come in and the processor does the processing, and then you have the processed data here. As you can see, there's a queue of new instructions coming in, and the processor is doing its job, and then we get kind of processed data out of it. Now there's a problem with this approach, especially in the past couple of years, and the problem is that we can only make this processor faster to a limit. There is a frequency limit, and the reason there are plenty of reasons actually, but one of the important ones is heat, because these processors are very, very kind of condensed, so the amount of heat generated by electrons moving through the processor is very, very high. And that's one of the reasons why we can't really increase the speed of processors, one single processor, because it will melt down. So because of this reason, we had to take a different approach. So if we want to increase the speed, but we can't really increase the speed in one single processor because of heat, then what can we do? So one thing we can do is to increase the number of processors. This way we have two processors running simultaneously and we divide the tasks between these two processors. This is called parallel computing. Two processors running at the same time, doing the calculations, and we divide the workload between these two processors. Of course, this introduces a new set of potential problems, and one of them is more bugs, because you should know when first which instructions you need to divide and what instructions need to be dedicated to each of these processors. Because let's say that you assign kind of a process to this processor here, and that task gets done fast, but this task is dependent on a process which is currently being run by the other process here. So you can have a kind of latencies, you can have a different kind of problems when it comes to writing programs for parallel systems. Of course, majority of computers, especially since past couple of years, all the computers are running on multi-core
can
processors,
understand
so
now
that's
what
another
is
thing.
parallel
Each processor in the modern
processor or parallel computing lah, kan?
Yeah.
Okay, so like he said in the end of the video, it says lah macam Intel quad core, Intel dual core. It means that if quad core, meaning your computer have how many processor? If quad core, who knows?
Uh, um, quad
Yeah,
core.
quad.
Yeah, forgot.
Noel, tahu tak? Can you guess how many processor inside your computer if your computer using quad core ke dual core? Can between the two lah, dual core and quad core.
Is it four?
Pardon?
Four.
But how many?
Four.
He said 4.
Four. For what? Quad or dual?
For quad.
Quad. Dual?
Two.
Okay. So Kelvin, can you guess the quad and dual core?
Yeah,
How
4 and
many
2.
processor it use?
4 and 2.
4 and 2. Okay, yes. Okay. Further, quad is 4, dual is 2. Okay, so
Okay.
all of the modern computer uh, usually using a multiprocessor lah. Okay, more than one processor in your computer. Okay, so okay, we already cover this. Okay, interleaving. Okay, so now multiprocessor. So how the multiprocessor process multiple processes at one time is by go through the interleaving process and overlapping. Okay, so interleaving meaning like I said just now, it must ganti-ganti, but in this time it also can overlap because it use multiple processor kan, so that's why it can overlap with each other. So meaning it doesn't matter either the first process running or not, and the second process also can start. Okay, so it doesn't need to wait. So of course this type of what process where we use multiple processor, it offer a faster performance of our processor lah. So that's why all of the processor that in the modern days like today it uses the multiple processor. Okay, so we proceed to the tightly coupled system lah. So these are the tightly coupled system, meaning it is how the tightly and loosely coupled system is actually the approaches of how the multiple processor is arranged or how it is organized in your computer lah. Okay, so all the computers are in tightly coupled configurations. Okay, so it says here, all of the computers that we are using now, it uses the tightly coupled configurations. Okay, so this tightly coupled system, it have access to the same program and data in the shared memory and input-output devices. Okay, so just remember, tightly coupled system, it shares the same data and program. It shares the same memory and input-output devices, but of course, it use multiple processor lah. It has more than one CU or control unit and PU, but it use the same memory and the same input-output devices. Okay, so program executions are divided among the CPU because there are more than one CPUs kan. So program execution will be divided among all of the CPUs. Okay, so ready process may be run in the CPU that is available so that the each of the additional processor can extend their power. And then each CPU can operate independently, meaning there are no communication channel is required, and each CPU access to the same memory and I/O devices. Okay, so this is the same like the above lah. This fact it is same lah, meaning tightly coupled. It has different CPU, meaning it has more than one CPU, but it shares the same memory and input output device. Okay, so this is the diagram that can visualize what is the tightly coupled system. So you have a different or more than one CPU, and then you have one system bus. This system bus have access to the shared memory, and then it also has the connection to the same input-output devices lah. Okay, so this is what is tightly coupled. Remember, the difference is only it shares memory, it shares the same memory, it shares the same input-output devices. And this is the generic block diagram for the tightly coupled multiprocessor. So this is another diagram lah to show what is a tightly coupled microprocessor. Okay, so it has more than one processor. It use the same buses, and then it shared one memory, and each of these input-output devices it can be all of these processor can access it can each of these processor can access each of these input output devices, meaning the 1, 2, 3, all of these three microprocessors can access this input output, all of this can, all of this CPU can access this input output. So all of this processor also can access the input output devices, meaning each of the input output devices that connected to the computer can be accessed by all of the CPU. Okay, so it shares one same RAM or memory. Okay, so more on the tightly coupled system. So theoretically, any program inside the memory can be executed by CPU as long as the CPU is free. Okay, so but this will raise the question of control of the system. Okay, so how our computer can handle more than one CPU? Okay, so how our computer will know which CPU will do what process? Okay, takkan derang mau berebut kan? Okay, so to handle these questions on how our system can handle more than one CPU, it can be answered by these two-way configurations, which is master-slave processing and symmetrical process multiprocessing or SMP. Okay, so as you can see here, a tightly coupled system, it memang shares the same main memory and the same input-output device. So here also the same lah. But the difference is for the master-slave processing, it has one processor that act like the boss. And then the others processor will act as the slave. Okay, so this actually should be here lah, because it is PDF, so I cannot edit this PDF. So this slave CPU should be this here. Okay, so master slave multiprocessing means that one CPU act like a boss, and then the others will act like a slave. While for the SMP, symmetrical multiprocessing, each of the CPU will act independently. Tidak siapa-siapa yang akan mengarah, but they will know, they do their own task. Nobody ordering something lah. But who will make them working without any problem is the OS. There will be an algorithm that is coded into the operating system that will make each of the CPU working independently without fail. Okay, so without no boss. Okay, so this is another detail of the master-slave multiprocessing lah. Okay, like I said just now, one CPU set as the master. This master will manage the system, will control all resources and scheduling. Okay, so and only master can control the OS, the operating system, while the other CPU or the slave will perform the work assigned by the master. Okay, so I think this one is easier to understand lah. Yes, after that, master-slave multiprocessing is useful when slaves are assigned specific and non-tasks that can be executed relatively independently. And this is the case, for example, with the cell processor, which is used in the Sony PlayStation 3 game controller. So remember, imagine that you have a used cell processor when you are playing Sony PlayStation 3 game controller. Okay, so who who have played this game previously? I never played that game lah, so I don't really have the imagination on how we can play that game.
Long time ago already.
Long time lah, but you have lah, pernah lah kan?
Oh, yeah.
Ya,
Okay,
pernah.
so, wow, memang oh, all of the boys memang play game oh, kan? Okay, so I don't have the imagination, but maybe you can imagine lah since you have used this PlayStation. Okay, so the slave performs specifically assigned graphic processing tasks which compute intensively. So all of the slave will do the graphic processing task and it will reduce the burden on the master CPU lah, because all of the tasks, the tasks that all the tedious task is done by the slave. The CPU, the master only need to order sajalah or schedule which should do first, which should run first. Okay. Okay, so the advantage of this master slave multiprocessing is it is simple. It is said to have a better protection because the system is tightly controlled by the master CPU. Only one CPU that can control all of the process, so that's why it is the system is strictly controlled by the CPU lah. So no other things that can interrupt that master. But the disadvantages is it has low system reliability and it may have a delay in job scheduling. Maybe if there's too much job at one time, and then even the master CPU also need time to schedule each of the tasks which slave CPU need to do that. Okay, so it will make the heavy burden for the master if there are too much processes, and because it is the only the master that can assign the task kan, so everything waiting for the master, so it can heavily burden the master.
What?
Okay, so we proceed.
Why is there delay in job scheduling?
Delay in job schedule ni because if the master, if there's a lot of processes come at one time, the master need to schedule each of the processes to which slave. Okay, so it makes if the master processor lambat buat kerja, then a lot of the task is in queue lah. So that's why it can delay the job scheduling. Okay?
Okay.
Okay, so we proceed to the SMP, which this SMP, it has no master. All of the CPU is the master of itself. Okay, so each CPU has equal access to resources, and then each CPU determines what to run using a standard algorithm. So like I said just now, it uses a standard algorithm, and that standard algorithm is coded to the operating system, and that operating system that will assign which CPU should do what task. Okay, so the task of the master CPU in the master slave architecture is now taken by the operating system. Okay, so what algorithm? We don't know lah what is the algorithm because it is not covered in this lecture lah. And this is the diagram for the SMP lah. So each of the CPU have its own this one is also its own local memory. So if you remember, there's a L1, L2, L3. We have learned this previously, so it is considered as a local memory. Before it come to the RAM, there's another faster memory kan. So that the faster memory than the RAM is the L1, L2, and L3 itulah. So in the symmetric multiprocessor, each of the processor has its own L1, L2 or the local memory. But because it is still in under tightly coupled system, so it still shared the same RAM, it still shared the same I/O devices. But the only difference between the asymmetric SMP with the multi-slave is multi master slave has dia punya master, but for this SMP each of it has dia punya own each of it is a master of itself lah, and it has its own local memory. Okay, so these are the characteristic of SMP. Okay, so there are two or more similar processor of the comparable capability, meaning the processor will have the same capability. So these processors will share the same main memory and the same I/O facilities because it is tightly coupled system or architecture. And then the processor and the main memory and the facilities, it is interconnected by a bus or other internal connection scheme, such as the memory access, such that memory access time is approximately the same for each processor. So it use all of this, it is connected using a bus and other internal connection scheme. And then so it will make the memory access time will be approximately the same for each of the processor, meaning processor A, B, and C can have the same time when they are accessing the memory. Okay, because it used the same buses. After that, all processor shares access to the I/O device, yeah, like the previous statement also. So either through the same channel or through different channel that provide path to the same device. Okay, so each of the processor, I mean all of the processor, like I said just now, it can access all of the input-output devices that connected to the computer. Either it is using the same channel or the same buses, or it uses different channel. But the main point here is all of the processor has this can access all of the input output devices. Okay, so all processors can perform the same functions. Okay, so there's no boss, there are no slave, they are all the same. They all can do the same functions. Okay, so the system is controlled by an integrated operating system. Okay, so the standard algorithm that is mentioned previously is coded into the operating system so that the operating system can provide interaction between processor and their program at the job, task, file, and data element levels. Okay, so like I said just now lah, the master all the tasks of the master processor is taken by the integrated operating system. Okay, so these are the advantages of SMP. So in terms of performance, it can provide a greater performance compared with the single processor. So it didn't say that this SMP is better than master slave lah, but it says here this SMP provide a greater performance compared to the single processor. Okay, so it can support incremental growth, meaning if the user want to enhance the performance of the CPU, the user can anytime add additional processor. So if you are brave enough, you can experiment your computer, laptop, check either you are using SMP, but all of the, like it says previously in the previous slide, all of the computer nowadays using SMP kan. So if you are brave enough, you may check your processor, your laptop processor, and then maybe you can add by yourself manually, add another processor in your laptop. But if it go wrong, don't don't find me, don't seek for me, because I also don't know. I never open my processor. Okay, so another advantage of SMP is the availability. Because all processor can perform the same functions, the failure of a single processor will not stop the other machine or the other CPU lah. And instead, this system can still continue to function, but only it will reduce the performance lah, meaning it will slow down a little bit lah. Okay, so scaling. Another advantage is the scaling. Vendor can offer a range of product with different performance based on the number of processor configured in the system. Okay, so this scaling advantage is more to the vendors lah, meaning the seller of the laptop or of the laptop lah, because they can offer for the laptop that has more processor, then that they can offer higher price lah. And for the lower or the lesser processor, they can offer lesser price. Okay, so now we proceed to the loosely coupled system. So this is the difference between tightly coupled and loosely coupled is each system is complete in itself. Each of the system has its own CPU, it has its own memory, and it has its own input-output facility. Okay, so each system is known as a node of cluster. Okay, so each of the set of the CPU memory and the input-output facilities is known as node of cluster. Data communications provide the link between the different computers. So how each of the node of the cluster connected to each other is through the communication channel. Okay, so this loosely coupled system also known as clusters or multi-computer system. Okay, so if you can see, this is the diagram of loosely coupled system. So this is the node 1, node 2, node 2. Each of this node has its own CPU and it has its own shared memory. Okay, so the only things that they share together is the external disk. Okay, so Meaning each of these is one computer, one computer, one computer, one computer. Okay, so but all of this computer is connected with one shared disk. And then this is the advantage of the loosely coupled system lah. It is fault tolerant, meaning if one node faulting, uh, the others will not affected, but it only can slow down the process a little bit. And then it is scalable, meaning you can anytime add or remove any of the nodes, and then it is well balanced because each of the nodes it has its own unit, and then the distance is not an issue. Okay, so the advantage is scalability is limited by bus bandwidth and latency and by available memory. So even though it can be anytime can be removed, anytime can be added, but when you want to remove or when you want to add new node, you also need to consider the bus bandwidth and the punya latency, and then how many available memory uh, that can be shared between all of the nodes. Okay, so we proceed to the multi-processing operating system. So multi-processing operating system is the operating system that apply the SMP architecture. Okay, so SMP, the multi-processing operating system is a SMP operating system. It manage processor and other computer resources. Okay, so multiple jobs or process may be active at one time, and it is responsibility of the OS to schedule their execution and to allocate resources. Okay, so multi-processing operating system is the one that takes the master processor punya job lah. So because it is SMP kan, so the SMP will be managed by the OS. So the OS that manage or that has this SMP is called as multiprocessing operating system. Okay, so a user may construct application that use multiple processes or multiple threads within the processes without regard to whether a single processor or multiple processor will be available. Okay, so user don't need to know either your computer using multi-processor or single processor, because it will be handled by this OS. Thus, OS must provide all the functionality of a multi-programming system, plus additional feature to accommodate multiple processes. Okay, so the OS not only needs to manage the schedule between each of the CPU, but it can also have additional feature to assist any process that is needed to run multiple processes. Processes. Okay, so we go to the new topic, which is the design consideration. Meaning, when you want to design a multi-process operating system, these are the items that you need to consider. Okay, so there are more than there are 1, 2, 3, 4, 5. Okay, five design considerations, or the items that you need to consider when you want to design the microprocessor OS. Okay, so first is the simultaneously concurrent process. So when you design the OS need routinely allow several processors to execute simultaneously, and with multiple processors executing the same or different part of the OS tables and management structure must be managed properly to avoid deadlock or invalid operations. Okay, so this is actually too general punya statement, but for the person or like a Microsoft, they will really know about this because they are whatever company that develop an OS, they should know how to avoid deadlock, how to avoid invalid operations. These are the things that they will consider when they are designing their their OS. Okay, so that's why there's a various version of operating system out there. Each of them will be different in their way of managing the simultaneous processes, and then managing the scheduling. Okay, so each of the OS out there that is available in the market will be different in this criteria lah. This is like the criteria that they will take into consideration when they're designing the OS. So the second criteria or the consideration that need to be taken into account is scheduling. So any processor may perform scheduling, so conflict must be avoided. Okay, so your OS should be able to avoid the conflict lah. Okay, so the scheduler must assign ready process to available processor. So your OS should be able to make the scheduler only assign the ready processors to the available processor. Okay, so another consideration or criteria need to be considered is the synchronizations process. Okay, so with multiple active process having potential access to shared address spaces or shared input-output resources, the care must be taken to provide effective synchronizations. Meaning, if you want to design an OS, you need to consider how multiple active processes need to access shared input-output resources lah. So synchronization is a facility that enforces mutual exclusion and event ordering. So that is what is the definition of synchronizations process. Okay, so another criteria to need to be considered when you design an OS is reliability and fault tolerance. Meaning the OS should be provide graceful degradation in the face of processor failure. Meaning the operating system must provide a better procedure when they face the processor failure. Okay, so the scheduler and other portion of the operating system must recognize the loss of processor and restructure management table accordingly. Okay, so if the OS should be able to manage the scheduler to restructure the management table when there are one processor lost or fail. So we can, from this statement, we can assume that in the operating system, there will be a management table that will be referred by each of the CPU to see their schedule. Okay, so after that, another consideration that need to be taken into account is the memory management. So the OS should handle all of the issue found on uniprocessor machine. So if you are using only one processor, the OS should be able to handle all of the issue if you are using one processor. So the OS also need to exploit the available hardware parallelism to achieve the best performance. Okay, so the OS need to know or need to exploit lah the available hardware so that all of the meaning dia macam can know which path the best so that it can achieve the best performance. It can perform at a better speed. So the paging mechanism on different processor must be coordinated to enforce consistency when several processors share a page or segment and to decide on page replacement. Excuse me. Okay, so so finish with the parallel processing. So in this chapter, we have learned about. Okay, so I will ask, what do you remember that you have learned in our past previous 1 hour? I will ask Farah first. What do you remember?
Um, One thing I remember is the master and slave something.
Oh,
That one.
okay. So what is the macam opposite with the master and slave architecture tu?
What's the forgot the name. Is it the C commercial? I forgot the opposite.
SMP. It is the
Oh yeah.
SMP. Okay, so SMP is uses by all of the computer around the world. Okay, so our computer ni we are not using master slave punya architecture lah. I mean how the CPU is organized in our system, in our computer. But it uses SMP, which all of the CPU has their own independent master lah, meaning they are their master on their own lah. Okay,
Okay.
so only that lah yang paling you remember.
Yeah, only on that one, the master and slave. That one.
Okay, so Kelvin, what do you remember?
The tightly packed.
Tightly
The
coupled.
parallel processing need to share
Ah,
to do the process better.
ah. Okay, so what is the one? I mean, what is the share? What is the tightly coupled kan versus with the loosely coupled system? So there are one difference between the tightly coupled and the loosely coupled. So what is the thing that is shared in the tightly coupled system?
processor.
Processor? Is it?
Isn't it?
No.
The process.
No. Who knows? The
CPU.
title. Pardon?
CPU. I don't know.
No. Remember, for tightly coupled and loosely coupled, it all have it is actually the architecture for more than one CPU. So they didn't share one CPU. They has their own. I mean, they has more than one CPU. They didn't share the CPU. They share two things. I mean, in the tightly coupled system, each of the CPU shared two things. Noel? No kah?
No.
Okay, so before I explain again about the tightly, what is the items that they shared? So I will ask Noel first. So what do you remember in our past 1 hour lecture?
The failing topology, the 4 types of processing.
Oh, so what is one of the type category?
One is the single instruction, single line.
Oh, after that?
And then got the single instruction, multiple line.
Mm.
Yeah.
How many? How many the categorization?
4.
Yes. Okay. So for the tightly coupled, so we repeat again lah only that thing. Tightly coupled, it shares memory and input output devices. But for the loosely coupled, it didn't share memory and input output devices, meaning it has their own memory, it has their own input output devices. Okay, Kelvin?
Okay.
Okay, so because we have about 45 minutes left, so to make your to use this to optimize this time, I have uploaded a tutorial for this chapter in our Google Classroom. So you guys answer that during this time lah, because we already finished our lecture on this chapter. So to make your memory lagi cepat ingat, so you can you answer that questions in the tutorial questions lah. Okay, guys.
Okay.
So if you finish, then I mean you can just you submit that lah, and our session can be dismissed now. If you don't have any questions lah. So do you have any questions?
So far, no.
Okay. So if you have any question, like usual, just chat in our WhatsApp group lah. Okay. So bye guys.
Okay, Miss. Thank you.
Okay.
Okay. Bye.